Okay. Now we had a problem that was something of this form, maybe not this exact form, because we might have had some other constants and so forth. But it's like an mv prime, which is a force, okay, equals, it's actually a qv cross b, and I didn't put the q in here, and I'm not going to try to insert it, because I just started out by writing v cross b to show people what v cross b meant. Okay, and I think in the context of that problem, b was a vector in the direction of the k vector, in other words, in the positive z, in a z direction, whatever b is. And v is some vector in the plane which has a vx and a vy component. Okay, now this means component, not x derivative and y derivative. I could as well have written this v1i plus v2j, but I wrote vxi plus vyj. X component, y component of the velocity. Well, I do the cross product. I don't have to do a big old determinant to do that. The I and j vectors are commutative and not commutative. You have a distributive law and associative laws and so forth that allow me to write this as Vx times I cross Bk. And I think I lost my B. Maybe I better insert that. There should be a BK. I don't really have a good place to put that, but I'll get a little sloppy here. Okay. Well, it should be really Vx times B, then times I cross K. Okay, I cross K, you know, I, K, negative J. So it's negative, this would be negative Vx times B times J. And then I've got a J cross K here, which is an I. So I have Vy times B times I. I have a B here, and there's a V here. I'll be a little sloppy about that. Okay, well, V prime is just what? It's Vx prime I plus Vy prime J. So now what do I have? Well, my I component here has to equal my I component down here, which means that M times Vx prime, if you look at it carefully, has to equal Vy times B. And then the Vy prime times J has to equal the negative Vx Bj, well, B times M times all that. And there's no B here. Wasn't supposed to be there. B's over here. Okay, well anyhow, the M Vy prime J then has to equal the Vyb times, the negative Vxb times J. J component equals J component gives us an equation. I component times I component gives us an equation. What's this? This is just a system of two linear equations. Instead of Vx and Vy, now I could write these V1 and V2. So maybe I have the equations that would reduce to V1 prime equals, write it as 0 V1 plus Vy, well, plus B over M, and you can't read that, but it's B over M, times V2. And this would be V2 prime equals negative B over M times V1 plus 0 V2. Okay? So there's our system. Now the whole system could be written as V prime equals 0 B over M, negative B over M, 0 times V where V is V1, V2, or if you want to keep it in X, you could say it's Vx, Vy. All the methods we've used apply in this case. So you can solve this in one way or another. The basic idea is that you get two equations and two unknowns, one for the I component and one for the J component. In a more general case where everything's in 3 dimensions, you could get 3 equations and 3 unknowns. It'd be a little more complicated, but all the methods that we've used apply to that kind of a system.